Good morning, everyone. I hope that everyone's been able to be safe during this time. It seems that everything's moving in the right direction here in Vancouver, so I'm sure that we're all looking forward to returning to normal. Here at CIM Vancouver branch, we're still trying to assess what that new normal means for us. And as part of that, we're beginning a transition to offer all of our content in a digital format. For the time being, we're going to be assuming that this is going to continue for the foreseeable future. But it's important to us to continue engaging with our community as best we can, and do intend to ramp up with these sorts of webinar events in the coming months. So please ensure to follow the LinkedIn page and the email circulars that are going to be released with the upcoming schedule of events with the speakers assigned to them. As this is our first webinar, I do apologize if we have any technical challenges. I'll do my best to ensure that there aren't any interruptions, and those that do happen are short-lived. Regarding format, I'll be planning to make a few announcements here, and then our speaker Brent will make his presentation. At the conclusion of his presentation, we'll have a short question and answer period. So if you do have a question during Brent's presentation, feel free to type it into the chat box or Q&A box, which is in the bottom right-hand corner of your screen. At the end of his presentations, we will address all the questions that have been raised, and if you have any in addition, we'll be providing his contact information that you can reach out directly for him. As we transition to a digital model here, we're continuing to provide our CIM Vancouver annual branch sponsors exposure. Please keep updated to the LinkedIn page, as we're going to be circulating coverage of our sponsors over the coming months. As you know, this year we've have 2 levels of committed sponsors, both gold and silver level. Our gold level sponsors include Bedrock Service and AMC Consultants. At the silver level, we have Merit Consultants, Pan American Silver, and SLR Consulting. As most of you know, this week actually was the intended time for hosting of the CIM National Conference and Trade Show that was supposed to be here in Vancouver. Obviously, we're unable to hold that event, and in lieu of the physical face-to-face meetings that were supposed to be held, XCOM and National Council did have meetings over the weekend, and all of the normal procedures did take place. So our CIM president for the last 12 months, Roy Slack, has now concluded his term. He'll now step into the immediate past president role. Our new president, Samantha Espley, after serving for over 30 years with Vale in Sudbury, becomes our new CIM president with a term from May 2020 to 2021. In line of succession, we have our president-elect, Pierre Julien from DRA Global, and most recently nominated incoming president-elect Anne-Marie Touton, who just recently retired from Suncor Energy, whose term will begin in 2020 and last until 2023. As we all know, every 2 years, the CIM Vancouver branch does have a executive committee shuffle. It's important that we continue to rotate through professionals who want to contribute to the CIM Vancouver branch to ensure there's fresh ideas, and to ensure the continuity of our efforts. So this will be my last event as part of the CIM Vancouver branch. I'll be stepping into the past chair role and into a role as the first year VP for the Western District with the National Council. Yvonne DeBoer will be staying on as co-chair of the YVR branch, and incoming co-chair Mary Jane Piggott will be joining her to help lead the efforts of the executive committee. Laurie Mayer will join the branch as vice chair, coming from his past role as sponsorship director, technical director. Netta Farmer, John Gravel, and Ron Gill will respectively remain in their roles as venue and registration director, secretary, and treasurer. And then we have some new phases that are coming to contribute. Two new technical committee members, George Darling and Sherman Tamuri, and a new sponsorship committee member, Tad Karawi. Andrew Mitchell is now in his second year as sponsorship chair for the branch. Marketing director is Mehmet. He'll be the principal person managing our social LinkedIn pages, ensuring that our content is effectively distributed. Most importantly, we've got a long-term advisor in Tom Brody, who's been with the branch for a number of years and is integral to help us navigate various strategies and efforts moving forwards. And this year, there's been an effort to have a renewed integration with both BCIT and UBC. And Cole and Satish, thank you for your contribution as your student liaison representatives for the CIM. And both Cole and Satish will be joining us on the executive committee for Vancouver branch, helping to grow and facilitate the relationships that we do have with both universities. One of my favorite announcements today, congratulations to Netta Farmer, one of our executive committee members here at the Vancouver branch. She was awarded the 2020 CIM Distinguished Service Award. And I know that I'm speaking for the entire executive committee of our branch. We wouldn't be where we need to be without her contribution. So our community is definitely in debt to her level of service that she's provided us over the last number of years. While we all would have loved to provide you a round of applause at the CIM Awards Gala this year, obviously that didn't happen. So we'll hold our applause until you have the opportunity to walk across the stage in Montreal in 2021. Continuing from our February event, the CIM National is continuing their efforts to recruit mentors as part of the CIM Mentorship program. At this time, there's approximately 50 people which have decided to contribute time from their week, with 15 or so from British Columbia and a majority of them from the Vancouver Regional District. As we might expect, the school year has now concluded, and a lot of the students who had initially had summer placements or full-time jobs lined up upon conclusion of their studies have now entered into a fairly uncertain time with travel restrictions and challenges of beginning their own careers. So I think that really this is paramount and important timing for those of you who do have a couple hours a week to contribute to the next generation of mining and metals professionals that you do so. I would expect that the CIM National Committee is still quite interested to receive contributions from those in our community here in Vancouver. Again, as we begin this transition to managing the CIM Vancouver branch in a digital format, I urge you, if you're not, to become a member of our LinkedIn page. At this point, we've got over 800 members who consume and contribute to content. All of our industry news and events advertisements will be placed on that LinkedIn page. So we're continuing to look at avenues to exercise new strategies and new new content that's going to be placed on the LinkedIn page, and so it'd be good for you to check it out if you haven't become a member yet. Today, we have the luck of having Brent Hilscher from ABH Engineering to provide us a presentation on ore sorting 5 years of progress. Brent is a stalwart in the BC mineral processing community, and funny enough, I think actually the first CIM presentation that I went to in the Vancouver branch 5 years ago was Brent's update on the status of ore sorting. So this is a little bit full circle for me, from my first event to my last event. Brent has over 20 years mining experience and mineral processing experience. He's designed, commissioned, operated, and supervised mineral processing plants, published papers, patented technologies, and has been a speaker at over a dozen conferences and universities across Canada and around the world. He won the National CMP Bill Moore Award for Technical Excellence in 2013 and served as an officer in the Canadian Armed Forces. Because of his technical reputation, Brent has consulted as a senior advisor for the World Bank, United Nations, and Government of Canada. And most importantly, he is a long-term volunteer as an executive for both the CIM and the CMP. So thanks to Brent for contributing your time today, and I'll hand over the keys to you for the remaining part of the presentation.
It's time to move forward with this. So who is ABH? ABH is a relatively new engineering company, fairly small. We've got some PhDs and masters and myself. Most people have over 20 years experience. We do a lot of technical process work, but also a bit of mining work. We do a lot of ore sorting, of course, because that's what I've done the last few years. We're 100% independent, so we don't have any particular technology that we're pushing. We can use any technology. It just depends on the operation. So this presentation's new. I put together just for this. It's looking at where we were 5 years ago and where we are now. In some sectors, a lot has changed. In some, there's been progress, but it hasn't been dramatic. And we'll take a look at all those things. Right, disclaimer. We love all the other pre-concentration technologies. I'll build, DMS plants and whatnot. This is just talking about ore sorting because that's kind of the hot topic. I assume everyone still remembers we have other technologies. So just because I'm not talking about them doesn't mean I won't put them in the right situation. And as an example, here's, HydroFloat, which is lovely. And there's a little video, an animation of it, which is very cool that they let me use. Everyone seems to love animations because it really drives home how things work. So here we see, instead of a typical flotation cell, which is very violently churning, this is a little more of a calm process where you have one or more bubbles helping those really coarse particles overflow. And you also have the slurry overflowing. So it doesn't have to join a froth bed in order to overflow. So this lets you reject very, very coarse material, at least coarse by flotation standards. So this is an example of one of the new and effective pre-concentration technologies. Anything that lets you reject material while it's still very coarse is a big benefit. So 5 years ago for ore sorting, there was definitely industry perception issues. That was seen as a very neat technology, but not something that anyone would seriously put into a flow sheet. Particle sorting was definitely ready for wider applications, but it hadn't gotten there yet. It had been installed maybe a dozen places, but they weren't well known. They weren't well publicized. Not a lot of people had seen them at presentations. They didn't know people who had put them in. So it was, as we'll see earlier, it was the early start of the adoption curve. And bulk sorting definitely still had some issues back then in terms of speed. And then we'll see some of its progress. Again, people love videos. So here's a video of a ore sorting system. I used to show a lot of Steinert videos, so now I show a couple of Tomra videos every now and then, just to spread the love. Everyone should know what this looks like by now. I'm just including this for the few people who aren't familiar with it. You feed into one end of the system, it spreads it out over a wide conveyor belt. As the rocks come flying over the edge of the conveyor belt, a sensor will look at each rock and say, is this rock ore or is it waste? And in this case, we're using dual energy X-ray transmission, which is fantastic. You could also be using laser, color, infrared, ultraviolet. There's electromagnetic. There's a very long list of sensors that we can be using to identify what's worth keeping and what's worth rejecting. And as these rocks fall over the edge, air jets divert them at, could be 200 tons per hour into the proper bin. And yeah, that's that. Easy peasy. This iteration of the technology has been around 15, 20 years maybe. So it's very well established. It's not in any way out there. This is an example of bulk sorting. In this case, we have prompt neutron gamma activation analysis, which just rolls off the tongue. Neutrons are emitted either electrically or nuclearly. I don't know if that's a word. And impact atoms, those atoms re-emit gamma rays. Those gamma rays have a very specific signature to the atom they came from, are detected, and you can take a number of counts. So you know the elemental analysis of what's on your conveyor. So this is an example of bulk conveyor sorting. There's other systems that can use XRF or laser or other things, but generally it looks something like this, and you will divert the end of your conveyor based on the sensor reading. So today we've definitely reached a tipping point for industry perception, which is fantastic. Particle sorting's been having some incremental improvements in terms of tonnage and accuracy over the last 5 years, which has been very, very helpful. Bulk sorting, though, has seen some huge step changes in improvements in terms of speed and accuracy. Although mostly speed, I wasn't ever worried about accuracy of the conveyor sorting systems. It was always speed. You know, no one wanted to wait 2 minutes. We always wanted our results super fast, and we'll talk about that later too. So this is a world population graph, but I'm using it as mining adoption of new technologies graph. When a new technology comes out, there's a very, very long period of people looking at it saying, yeah, that's cool. We'll wait 10 or 20 years until everyone else has done it, and then we'll put it in. So ore sorting has gone through that long period, and now we're into the rapidly accelerating part of the curve. Starting to get it a little into the shortage of qualified people, where some crazy ore sorting reports have come out with, they're wrong. And, you know, we have to fix them, and that's okay. But it's getting to the point where we're going to need a lot more people who know how to do this in order to deal with all the studies and installations that need to be done. So this is particle sorting, an example from 4 of the operations that we did and that were good enough to allow publication of their results. One of the things that we did in the last 5 years was top left to top right, taking the grade recovery curves where you can see the computer algorithm has done its best to place all of the high grade rocks on the left and all the low grade on the right. And that's our grade recovery curve for a sorting system. We subtracted off tailings costs and milling costs to really give you an idea of the value being recovered. So in this case, you can look at the far right, you're starting at 50% profit recovery, and then you're going up to 90%. So you were losing a lot of profit because you were processing a lot of worthless garbage that it couldn't even cover the milling and tailings costs. Of course, this neglects the fact that you could replace that garbage with higher grade ore and make more metal, and that's always, you know, the business case that we end up doing in the end. But this is a nice little graph that shows you, what's the optimum mass pull? And you can then look back and say, oh, what's the optimum recovery? It might not be 98%, it might be 95%. And then below, on the bottom row, we see quite a few other operations. Generally some very good sorts. Green bars on the left, red bars on the right. That's always what we like to see. It leads to the grade recovery curves being very close to optimal. So what's been happening with bulk sorting? So conveyor and shovel-based systems are both proven in the field now, which is exciting. The accuracy and speed of all the systems has increased. It's something that the mining industry has been pushing the manufacturers towards for many years. Extra sensors, more powerful sources, things like that, where we explain to the manufacturers that capital cost doesn't matter nearly as much as speed and accuracy. If we can boost our metal recovery by 2% for the same mass rejection, that is huge, and that pays off any capital costs that might be associated with more powerful sources and better sensors. We've also seen some really neat new technologies emerging here, where we've got laser-induced breakdown spectroscopy. 5 years ago, that was just an interesting concept, something when people ask me, what do the next 5 years have in store, I could point to and say, well, laser-induced breakdown spectroscopy would be a great one if they could get that commercialized, and now they have. So never let it be said mining doesn't innovate. Magnetic resonance, like an MRI scanner, is now on the market. And that's neat because it doesn't look at the elemental distribution, it looks at the mineralogical distribution, which is something we couldn't do before. And I believe that's going to open up an awful lot of possibilities where perhaps sorting didn't work very well because there wasn't much of a difference elementally between two rocks, but mineralogically there was a very distinct difference, and it could be, a lot of times if this is a gold application, gold is associated with one type of mineral but not its sister mineral. Prompt neutron gamma activation has come an awful long way in terms of taking minutes to make up its mind. Now it's taking seconds, 2 seconds, 10 seconds, 20 seconds. So there's been a step change in that. Why that's so important is if we can make our decision faster, then the packet of material that will be sorted is going to be smaller and more selective. So if instead of sorting 20 tons at a time, we can sort 5 tons at a time or 2 tons at a time, the odds of that packet of material being extremely low grade is much higher. And the lower the grade of our rejects, the better our grade recovery curve is going to be. So shovel sorting, this is a Vancouver technology. MineSense has done some really nice work in terms of getting this to market. It's now installed at Highland Valley, not just as a test system, but I believe it's commercial. I hope I'm not giving away anything, but they've got multiple shovels now. Also operations in Chile, Alaska, and Ontario. So this is now commercially proven, ready to go mainstream, which is lovely to see. The laser technologies definitely coming a long way, especially in terms of pulses per second or pulses per minute, going from hundreds into thousands, so a step change. The more pulses per second you can have, the more accurate your scan of what's on the conveyor is going to be. The more samples you can take, because each sample is only small, the more useful this is going to be for gold and platinum group applications, which is really where this technology, I believe, shines. Because this can detect gold and platinum. This can detect sub-ppm levels of materials, provided you sample a mineral that has those, the gold or the platinum. So this is something I believe is going to potentially be very big in the next 5 years. Of course, we haven't done anything about bulk sorting's main nemesis, which is mixing. We see here a graph of different mixing levels. So say you only wanted to reject copper below 0.1%. Okay, great. If you haven't mixed your material very much, you can see on the left side there, you can reject 35% of your material. That's pretty good. But if you have mixed it, maybe you only 15% rejection. And if you've thoroughly mixed it, maybe you've added it to a coarse ore stockpile, well, now you might reject 5% because you've so thoroughly blended that material that it no longer can be effectively sorted at a bulk scale. Particle sorters, of course, don't care one bit because they look at individual rocks, so you can blend it all you want there. But bulk sorting needs to be as raw as possible. So ideally, your bulk sorting system is either shovel-based or your trucks dump into a gyratory or jaw crusher, and that feeds a conveyor which has the sensor on it. So some of the things we've been doing in the last 5 years, combining technologies. Combining particle sorting, especially dual energy X-ray transmission, with DMS technologies. Very helpful, especially since particle sorting has a minimum size, usually say 1/2 inch. 1/2 inch to 4 inch is sort of the nice area for most of those technologies. Well, everything under 1/2 inch, if XRT works, DMS might also work. It only looks at the average density of the particle rather than the histogram, but still, it could probably work. Also, it has the advantage of smaller feed size means better chance of liberation. So running particle sorting on all the coarse and DMS on all the fines really lets you maximize your grade uplift and your mass rejection. Particle sorting combined with bulk sorting is great, especially if you've got a mid-size open pit. Say you don't want to run everything through a particle sorting system because you've got too much tons. You run it through a bulk system first. Then the most appropriate grade to go to particle sorting is split off using the bulk technology. So perhaps only 30% of the total mass goes for particle sorting. Now your rate of return on your project can be much higher. Any sorting technology with co-disposal is a neat idea because any sorting technology tends to reject material that is very coarse. That's good because now you've got a pile of material that has air gaps in it, spaces. So you can look at co-disposal technologies where you take your fine ground material, of which you now have less, combine it with your coarse material, which you have more of, and your tailings pond isn't just half the size, it's a quarter of the size, or maybe it's gone completely. Even if you can't eliminate your pond completely, if it's a quarter the size it was before, now you look at something like tailings filtration and you say, well, we couldn't afford to filter all of our tailings. That was way too expensive. But a quarter of our tailings, so that's more reasonable. And then sorting with site reclamation to remove sulfides, where you look at a pile and the government says, look, you've got to clean up this pile, you're leaching acid, which is a reasonable request. So you were going to have to cap that or move it or contain it in some way. But if you run it through an ore sorting system, removing sulfides is one of the easiest things that we can do. So you remove all the sulfides, you now have a pile with 90% of its original mass. Non-acid generating can be used for all sorts of things. And you have a much smaller pile, which you can then process, extract the economic minerals from it, because generally if you do a 10-to-1 upgrade ratio on a lot of these acid generating waste piles, the 10% that you've extracted could be very economic. I've seen 6-8 grams per ton come out of waste piles. So this is the co-disposal and filtration for tailings example, which has been fairly popular. Normally you've got a ton of ore, becomes a ton of fine tailings, becomes a ton of fine tailings in your pond. And we've been doing that for a long time now. You put in an ore sorting system, and if it's very effective, in this case it was a silver operation, you put a ton in, there's some fines bypass and whatnot, but in the end, half a ton becomes fine tailings, and half a ton ends up in the pond, half the ton ends up in the waste pile. That's a very good result. Well, if you want to do some co-disposal, take a ton of waste rock if you have some. Now you've got a much larger place where you can put your fines with co-disposal. So maybe you end up with 2 tons in waste piles and 0 in your pond. You'll still want a clarification pond because you love your water chemistry and you don't want to ruin that. But it doesn't have to be constantly expanded. If it fails, it's not as devastating. Now, if you don't have extra waste rock, maybe you look into filtered tailings, because a 1/4 ton out of 1 ton filtering, that's not so bad. And maybe instead of doing a random filter, you put your finest fines into co-disposal and you filter more of your coarse material. So the filters not only have to only worry about 25% of the original material, but it's a fraction that's easiest to filter. So you save a lot of money. So why is that particular application important? Because we're not doing a great job with tailings. There's, like it says, a lot more than profit at stake here. This graph shows severity and frequency of dam failures is just increasing constantly, and it has been for decades and decades. Now executives are facing homicide charges. And this is a very serious thing, and the world is taking it very seriously. And this is our 100 years of failure graphs, where we look at the released volume from tailings dams and we look at the loss in human life. And even though our technology is improving, our results are not. So we have to do something very differently. So companies need to start looking into how they can eliminate these problems. Best way to eliminate tailings dam failures, eliminate tailings dams. And now there's technologies where this might be even more economic than building one. So if you can save money and not have a dam, well, why wouldn't you want to do that, right? So conclusions over the last 5 years. Yeah, mining definitely still innovates. It's that mining innovation can be a little bit of a joke sometimes, but we definitely do innovate. We just don't innovate as quickly as other industries. And there's a lot of reasonable reasons for that, because when you build a mine, you're stuck with that mine for 20 years. If you built the wrong grinding circuit, we're very sorry, but you can't fix that. If you're 5% below nameplate, you're either looking at a capital expansion or you're just stuck, you just deal with it. So in one sense, it does make sense for mining investors and mining companies to be extremely conservative. But on the other hand, if you're leaving huge profit margins on the table and you're exposing your company and your executives and shareholders to huge risk with environmental failures, well, that doesn't make much sense either. So there has to be a middle ground between those two. Particle sorting is, I think, well established now. I've seen quite a few conversations now where people are saying, well, of course we're going to be looking into ore sorting for this project. I'm like, oh, well, that's fantastic. So we've finally made it into the mainstream, at least for particle sorting. Bulk sorting, still a little bit behind particle sorting, but it's technically ready. So this is ready to go mainstream. We just need to start building more of these in open pits where it's more applicable, and start getting the word out there, publish publications, so that if we can really quantify the benefits, then more people will move forward with these things. Next 5 years. I made a prediction 5 years ago at the CIM in Vancouver, and most of those have come true, so let's try this again. Faster bulk sorting, for sure. It's going to continue getting faster and faster, and eventually The only limitation will be how fast can our diverter systems divert this ore. Particle sorting will continue to go mainstream to the point where it's a common sense step. You know, you check your flotation, you check your grinding, you check your ore sorting to see what the potential of any particular deposit is. It'll become just part of the standard metallurgical testing. We'll see larger particle sorting systems, and we'll see bulk sorting join particle sorting as an accepted technology. And what I'd really love is, if we could get laser-induced breakdown spectroscopy for particle sorting, that would be excellent. I'd love that. That would not be easy. That's why it's on the ambitious wish list. If we can get a really big step change in tonnage of particle sorting systems. You know, right now we do, say, 200 tons per hour. They're working on 300. If we could just skip over the hundreds and go straight to 1,000, that would be amazing. And there would be business cases for putting those things in, because if it's worth doing 200 tons per hour, it's still worth doing it at 1,000. Also, it would be nice to have a large and accurate XRF system for particle sorting. Often we have to make a choice between tonnage and accuracy. It would be lovely to have a big machine also very accurate. All right, so usually we have a ton of questions, so we've saved some time for those.
Awesome, thanks, Brent. There's a couple questions here. I'll address them one by one. So from Marie-Eve, if she understands correctly, LIBS is a surface technique. Is she assuming correctly that you recommend using a bulk analyzer instead of one using gamma to avoid a situation where the material is not homogeneous and therefore surface technique not ideal?
No. So LIBS is a bulk technology. So LIBS directly competes with PGNAA and MindSense in the bulk sorting arena. We haven't done a lot of commercial tests on LIBS yet, but its advantage is going to be that it can detect sub-ppm levels of precious metals like gold and silver and platinum. And right now, all of my gold work, of which most of my work isn't gold, that's all based on associations. So you can say, look, we're going to take all the sulfides and we'll get 98% of the gold comes with that. If you had a LIBS technology, you could measure that gold directly, which would be lovely. But a lot of testing is going to have to happen. We're going to need to quantify what is the loss of accuracy when you're doing surface scan only compared to a full belt. Also, I expect the PGNAA technology will keep advancing, and it's gotten to the point where PGNAA can also detect gold over a long time period. So if we can get to the point where that can detect gold over a very short time period, we almost don't need LIBS. So it's one of those, depends on the situation, depends on where the technology is by the time we do the study.
Okay. Could you describe for the attendees some of the manufacturers of various sensor types and those which have been proved at commercial scale? I saw that you put an example early on in the slide deck of a TOMRA piece of equipment, but I'm sure there are other alternatives as well.
I only got part of that question and then you froze. But examples of operators was what, oh, I hear it's my internet connection that's unstable. That's
okay, I can hear you now.
Okay.
So I'll repeat the question. Could you describe some of the manufacturers that have been proved at commercial scale? There was an example of a slide of using a TOMRA piece of equipment, but there's a question here looking at other alternatives. So if there are alternative sensor manufacturers or equipment manufacturers that you have familiar with.
There are so many. I hesitate to try to list them all because I will forget some and I don't want to hurt anyone's feelings. But there is, for particle sorting, TOMRA, Steinert, Rados, Redwave, Comex, and a few others. For bulk sorting, you've got MindSense, Scantech, the folks in California, sorry, I forget your names. And more.
Doug, if you've got other specific questions, I'm sure Brent would be happy to answer them through email.
Email me and I can send you a list.
Absolutely. Another question from Kenneth. Can you see closed circuit rougher cleaning sorting circuits in the future?
Can you do closed circuit? In terms of a circulating load around an ore sorter, so if you had 2 ore sorters in a row, one of them would be a scavenger feeding back. I don't know, we'd have to think about that. There are dozens of ways that we set up ore sorting systems. So yeah, anything's possible.
Okay. I have a question, Brent. Let's say you're a brownfield operator who is beginning to investigate the economic viability of installation of an ore sorting circuit. What would be the first step? I assume that there would be multiple metallurgical test work phases at bench and pilot level. Could you go through maybe what that escalation of test work and level of engineering detail looks like for a typical project?
So generally we have 3 phases of studies. The first is builds your associations, gets you your algorithms, really looks into detail of what will predict value in a rock. Second phase focuses on doing that with a representative sample. Third phase focuses on representative sample, but now multiple zones suitable for detailed design work. But the very, very first step is talking to the operation and asking, what is your projected tonnage? What is your projected grade? What is your mineralogy look like? What do valuable rocks look like compared to worthless rocks? And then all of those questions lead you towards the first assumption, which is bulk or particle. If you go the particle route, now you're looking at a subset of technologies. That's generally if you're underground or an open pit with surprisingly good grade. If you're a large high volume open pit, you're very probably looking towards bulk sorting technologies. So that narrows down the sensor types again. Yeah.
Okay. And another question here. There's a slide going through the mass balance of ton of ore to ton of tailings and rejecting that in order to reduce the fine tailings load on whatever management system they decide to implement. Co-disposal. So there's a project that I'm familiar with in Brazil that rejected product from an ore sorting circuit. They have a filter plant on the back end of that particular operation. And not only did the mass balance change into the filter plant, but significant changes in mineralogy actually improved the filtration profile because you're rejecting some of the gangue and more deleterious elements for filtration.
Yep.
So in your experience, I assume there is not just a mass balance impact, but there's also other forms of efficiencies that can happen within the circuit aside from just lowering the overall load of solids onto the plant.
Yeah, so there's a whole cascade of secondary effects because what we're doing is very early in the flow sheet and it can have a profound impact on extraction recovery, on work index, on your pore block model when you do your geomat work is going to be very different because each block is going to have its mass change by a different amount. Each block's going to have its grade change by a different percentage and its extraction recovery is going to change. So mine planning becomes a little more elaborate. And yeah, tailings, you're going to have less tailings. They're going to have a different chemical profile. If you're rejecting a lot of the clay substances and you're rejecting carbonaceous material, that's going to have an impact on what your tailings looks like.
Do we have any other questions from the attendees at this time? Okay, I don't see any of the others popping up here. So I would suggest, if you do have something that you'd like to ask Brent, his contact information is here on the screen. I'm sure he'd be happy to provide you some more insight. So thanks to Brent for spending the time today to provide this information to the community here in Vancouver. I'm hoping that in another 5 years, some of those ambitious goals maybe have materialized. So we'll bring you back in another 5 years and see if the second set of predictions have come true.
Excellent.
Okay. Thanks, everyone. Again, this presentation is intended to be uploaded. So if you know anyone that wasn't able to attend today for any reason, we'll be able to share this link and they'll be able to consume the content in a fashion that's more amenable to their schedule. Please keep up with the CIM Vancouver LinkedIn page because we will have upcoming scheduled events that will be carrying on through the rest of this year. Thanks again to Brent, and we'll hope to see you in another 5 years. Ciao.
See you then.
Bye-bye.